we're going to look here at actually solving these linear inequalities. So we've talked about union and intersection. We've talked about how to graph them. So now let's take a look at how to actually join these. So essentially the way we're going to do this is we're going to treat greater than, less than, greater than or equal to, less than or equal to, all the same as an equal sign. You know, so we can add something to both sides, subtract something to both sides, divide, multiply by both sides. We can treat it all the same as we would do if it was a regular equation, except, okay, if either you divide or multiply by a negative number. If either you multiply or divide by a negative number, you have to flip the direction of the sign. All right. So if you either multiply or divide by a negative number, you have to flip the direction of the sign. Okay, so if you've got something like 3x is less than or equal to 6. All right. Well, just like you would if you had 3x is equal to 6, you'd say, well, I'd go ahead and then, I divide both sides by negative 3, and I get x equals 2, or negative 2, right? Well, you can pretty much do the exact same thing here. I'm going to divide both sides by negative 3, but now, since we're dividing by a negative, we're going to flip that inequality. We're going to flip the direction of the sign. So now instead of being a less than or equal to, it's going to become a greater than or equal to. Greater than or equal to negative 2. And that would be our answer. So notice that if it was a less than or equal to, it becomes a greater than or equal to. If it has an equal sign, you keep it. If it doesn't, you don't. So if you had something a little bit different, if you had, say, 2x is less than 5. 2x is less than 5. You'll go in through here, and you'll say, well, I'll divide both sides by negative 2. And I got to flip the sign. And when I do that, I get x is greater than negative 5 halves. So again, the less than just changes direction. It doesn't become an equal to or anything like that. So if I had x over minus 2 is greater than or equal to 5, something like that. Now in this case, I've got to go multiply both sides by negative 2, right? And again, when I do that, it means I have to flip the sign. So x becomes, you got this one? X becomes less than or equal to negative 10. So the greater than or equal to becomes less than or equal to negative 10. Okay, super fun. Let's see what else we can do. All right, let's pull this down and we'll start a whole new set of examples. So say we've got something like 3 minus 2x is less than or equal to 11. Okay, so we can do just like we would if it was an equality. We can, first of all, get the x by itself, so we'll subtract 3 on both sides. Get minus 2x is less than or equal to 8. Divide both sides by negative 2. Since we're dividing, that means we flip the sign, since we're dividing by a negative. So we get x is greater than or equal to negative 4. Now when you solve these, usually they're going to ask you to graph it. So we've got a 0 and a negative 4. So we'll remember it's greater than or equal to. So, oops, see, I'm doing circles now. Greater than or equal to. So we're going to do a bracket. Greater than or equal to means it goes this way. Oops, why did it do that? Greater than or equal to means it goes this way. Okay. And then to write that in set notation, x such that x is greater than or equal to negative 4. And then to write it in interval notation, it goes from negative 4 to infinity. And we always use parentheses on infinity. So kind of like that. All right. try 3x plus 1 is greater than 7x minus 15. So you can get that one to work. Okay. And again, you know, it really helps whenever you're watching these to pause it and actually try to work the problem for yourself. That way you can check and see if you really understand what's going on. And if you don't, then you can watch the video and say, oh, that's how you do it. So, you know, when you get a chance, if you're so inclined, you know, go ahead and do this. I'm gonna move all my, what am I gonna do? I'm gonna move my x's over. You could do this the other way. You could also subtract 1 from both sides and move your 7x over, but I'm doing it this way because I want to show you something. So I've got 4x minus 15. And I'll show you the other way to do it because I'm feeling inordinately charitable. So I've got 16 is greater than 4x. Divide both sides by 4, and I've got 4 is greater than x. But that looks funny, right? That looks funny? Okay. So here's what you want to do. You want to flip this so that the x is over here. And if you're afraid you're going to get the sign going the wrong direction, remember, think back to like your little monster, your little angry fish is eating the big number. Your angry fish still needs to be eating the 4. So if your angry fish is eating the x before, he needs to keep eating the x. If he's eating the 4, then that's the number he needs to keep eating when you flip it. So I know it's goofy and dumb, and you're not 4 years old, but guess what? It's going to work. Okay, so you had over here, you had 4 was greater than x, and that flips over to become x is less than 4. Okay, so that's one way to solve it. And I just want to show you this because you might have done it the other way, and I just want to make sure that you see them both ways. So you could, instead of moving the 3x over, you could move the 1 over. So I've got 3x is greater than 7x minus 16. And let me subtract the 7x on both sides. And I'll get negative 4x is greater than negative 16. Now I'll divide both sides by negative 4. And since I'm dividing by a negative, I have to flip the sign. And I get x is less than 4. So I'm getting the same thing. It's just a different process. Okay? So that's kind of nice. If you don't feel comfortable flipping directions like this from here to here, you could always just say, I'm always going to make sure my x's are on the left so we don't have to worry about it. Just make sure that when you divide by a negative, that you remember to flip the signs. And then again, if we wanted to go in here and graph it, excuse me, if we wanted to graph it, we'd say 4, and it's less than 4. So I'm going to go this way because it's less than 4, so it's parentheses. And I'm good to go, less than 4. So to write it in interval notation, negative infinity to 4. And in set notation, it's x, such that x is less than 4. Funsies, yay! Okay. Let's try another one. Alright, try x plus 3 over 4 is greater than or equal to x minus 2 over 3 plus 1/4. Alright, now remember, pretty much anything that you did with a linear equation we can do to you with inequalities. So we're not going to give any squares or square roots, but we will give you fractions. So remember, when we solve these, we want to multiply by the GCD. That's one way to say it. We also call it the LCM. I think that's pretty much the same thing. Basically, you want to multiply the whole thing by 12. Because if I multiply this side by 12, and if I multiply this side by 12, that'll take care of it. So, in fact, let me just rewrite it like that. So I've got 12 times x plus 3 over 4 is greater than or equal to 12 times x minus 2 over 3 plus 1/4. Now I can go in here and distribute that going across. And over here on the left, I can tell that this 4 and this 12 will cancel out. I'll only have a 3 left. So that means I've got 3 times x plus 3 is greater than or equal to, and now over here I've got 12 times x minus 2 over 3 plus 12 times 1/4. So I can keep going over here and distribute the 3. 3x plus 9 greater than or equal to. Here's my 4. You should be getting good at this by now. It's the exact same thing that we've been doing so far, except we've got an inequality sign. But notice that we really haven't even done anything about the inequality right now. This is just solving an ordinary, just linear equation for all we know. We haven't really touched that greater than or equal sign yet. So I've got 3x plus 9 greater than or equal to 4x minus 8 plus 3. 3x plus 9 greater than or equal to 4x minus 5. So now I'm going to move my 4x over to the left, because I like having my x's on the left. It just makes me feel better, even if they're negative. And then I'm going to add my, I'm going to subtract my 9 from both sides. Got negative x greater than or equal to negative 14. Multiply both sides by a negative 1, or divide both sides by a negative 1, whatever makes you happy. You can have the same effect, as long as you remember to flip the sign. And when I do that, I get x is less than or equal to 14. So that's awesome, if you have a very low threshold for what awesome is. So less than or equal to 14, so I'm going this way. So x, such that x is less than or equal to 14, or goes from negative infinity to 14, inclusive of the endpoints. So that's super awesome. Now, we'll do one more, actually, before I get too excited. No, we won't. I want to show you something first that's more important to me than that. All right, let me show you something what could happen. So here's kind of a warning. So watch out for something like this. If you've got 2 times x plus 4 is greater than 2x plus 3. Okay, something like that going on. So you go through here and you're like, alrighty, I'm just going to do this. And I got 2x plus 8 is greater than 2x plus 3. And I'm going to subtract 2x from both sides. And that leaves me with 8 is greater than 3, and oh crud, I'm out of x's. So how do I solve for x? Well, we go back to what we talked about earlier, probably section 1.2 or 3 or something like that. But essentially you've got x, or 8 is greater than 3. So is this a true statement or a false statement? Is 8 greater than 3? Hopefully you got this one. This is a true statement. This is true. Does it matter what x is? Does it matter what x is? If x is 0, is 8 still greater than 3? Right? It is, right? If x is 9,824, does that matter? Is 8 still greater than 3? Yes. If x is negative 5, x is still greater than 3, right? So it doesn't matter what x is. This will always be true. That means that our solution is all real numbers. Remember the way we write that in interval notation, from negative infinity to infinity. Okay? So when you see this kind of thing, don't assume that you did something wrong. If it's a true statement, that means that your solution is all real numbers. Now, as a comparison, you could get something like this. X plus 7 is less than or equal to x minus 2. All right, so I'll go in here and I'll subtract x off of both sides, and I'll get another stupid statement without any x's. 7 is less than or equal to negative 2. So is this a true statement or a false statement? This is true or false? False? False, hopefully. You got that one? Does it matter what x is? Just nothing, right? It doesn't matter what x is. No matter what x is, this is never, ever, 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 ever going to be true. This is always going to be false, no matter what, right? Okay, so that means that there is no solution. No matter what x is, 7 is never going to be less than or equal to negative 2, so there's no solution, and it's the empty set.